Good morning, students. Today I am going to discuss the derivatives of inverse trigonometric functions. So, firstly, I would like to write all the formula for derivatives of inverse trigonometric functions, and then I am going to prove one by one. So, the first one is derivative of sine inverse x. The formula for derivative of sine inverse x is 1 divided by square root of 1 minus x square. And then the derivative of cos inverse x equals to minus 1 divided by square root of 1 minus x square. And the third one, derivative of tan inverse x is equals to 1 divided by 1 plus x square. And the fourth one is derivative of cot inverse x is equals to minus 1 divided by 1 plus x square. And the fifth one, derivative of secant inverse x is equals to 1 divided by x into root x square minus 1. And the last sixth one, derivative of cosecant inverse x is equals to minus 1 divided by x into square root of x square minus 1. So now let's start the proof of these derivatives of inverse trigonometric functions. And in that, the first one is, if y is equals to sine inverse x, then prove that dy by dx is equals to 1 divided by square root of 1 minus x square. Proof. Here y is sine inverse x. Now shift this sine inverse to left side, then sine y is equals to x. So we need dy by dx, hence differentiate this with respect to x. Derivative of sine y is cos y, and y with respect to x is dy by dx, equals to derivative of x with respect to x is 1. Therefore, dy by dx is equals to, shift this cos y towards right side, it becomes 1 divided by cos y. Now we know that one of the basic identity of the trigonometric functions, that is what? Sin square theta plus cos square theta equals to 1. So from this identity, cos square theta can be written as 1 minus sin square theta, and cos theta is equals to square root of 1 minus sin square theta. So therefore, from this dy by dx can be written as dy by dx is equals to 1 divided by, if cos theta is square root of 1 minus sin square theta, cos y should be equal to square root of 1 minus sin square y. I hope all of you understanding. Therefore, dy by dx is equals to 1 divided by square root of 1 minus. So from this equation number 1, if sin y is x, definitely sin square y is x square. And this is a formula for derivative of sin inverse x. That is what? 1 divided by square root of 1 minus x square. I hope all of you understanding. Now let us start the second one. So what is the second one? If y is equals to cos inverse x, then prove that dy by dx is equals to minus 1 divided by square root of 1 minus x square. So proof. Here y is cos inverse x. So shift this cos inverse to left, it becomes what? Cos y is equals to x. We need dy by dx. So therefore, differentiate this with respect to x. So derivative of cos y is minus sin y, and then y with respect to x is dy by dx equals to derivative of x with respect to x is 1. So therefore dy by dx is equals to, shift this minus sin y towards right side, it becomes minus 1 divided by sin y. Again, by using the basic identity of the trigonometric function, that is what, sin square theta plus cos square theta is equals to 1. Sin square theta plus cos square theta is equals to 1. So by using this identity, sin square theta can be written as 1 minus cos square theta. So if sin square theta is 1 minus cos square theta, definitely sin theta is equals to root 1 minus cos square theta. So therefore from this dy by dx can be written as dy by dx is equals to minus 1 divided by, so here sin theta is root 1 minus cos square theta, it means sin y is equals to root 1 minus cos square y. Sin y is equals to root 1 minus cos square y. Therefore dy by dx is equals to minus 1 divided by root 1 minus. So here from the equation number 1, if cos y is x, definitely cos square y is x square, and this is what, derivative of cos inverse x, that is minus 1 divided by square root of 1 minus x square. I hope all of you understanding. Now the third one, if y is equals to tan inverse x, then prove that dy by dx is equals to 1 divided by 1 plus x square. Proof. So here y is tan inverse x. Now shift this tan inverse to left side, then it becomes tan y is equals to x. Now what? Differentiate with respect to x. So we know the derivative of tan y is secant square y, and then y with respect to x is dy by dx, which is equals to derivative of x with respect to x is 1. Therefore dy by dx is equals to 1 divided by secant square y. So after shifting the secant square y towards the right side, now by using the another basic identity of the trigonometric function, so that is what, we know that secant square theta minus tan square theta is equals to 1. So by using this identity, secant square theta can be written as 1 plus tan square theta. So shift this tan square theta towards the right side. So dy by dx can be written as 1 divided by, so you observe here, secant square theta is 1 plus tan square theta. It means secant square y should be equal to 1 plus tan square y. So therefore dy by dx is equals to 1 divided by 1 plus. So from this equation number 1, if tan y is x, definitely tan square y is x square, and this is what, derivative of tan inverse x, 1 divided by 1 plus x square. I hope all of you understanding. Now the fourth one, if y is equals to cot inverse x, then prove that dy by dx is equals to minus 1 divided by 1 plus x square. So proof. Here y is equals to cot inverse x. Shift this cot inverse to left side, then cot y is equals to x. Now we need dy by dx, therefore differentiate with respect to x. So derivative of cot y is minus cosecant square y, and y with respect to x is dy by dx, which is equals to derivative of x with respect to x is 1. So from this dy by dx is equals to minus 1 divided by cosecant square y. Now by using the another basic identity of the trigonometric functions, that is what? Cosecant square theta minus cot square theta is equals to 1. So by using this identity, cosecant square theta can be written as 1 plus cot square theta. So shift this minus cot square theta towards the right side. So we got cosecant square theta is 1 plus cot square theta. So from this dy by dx is equals to minus 1 divided by. So cosecant square theta is 1 plus cot square theta. So means cosecant square y is 1 plus cot square y. So therefore dy by dx is equals to minus 1 divided by 1 plus. So from this equation number 1, if cot y is x, definitely cot square y is x square, and this is what? Derivative of cot inverse x, that is minus 1 divided by 1 plus x square. I hope all of you are understanding. Now the fifth one. The fifth one is, if y is equals to secant inverse x, then prove that dy by dx is equals to 1 divided by x into root x square minus 1. So prove. Here y is equals to secant inverse x. Shift this secant inverse to left side. Then secant y is equals to x. So we need dy by dx. Therefore differentiate with respect to x. So derivative of secant y is secant y into tan y into dy by dx equals to derivative of x with respect to x is 1. So therefore dy by dx is equals to 1 divided by secant y into tan. So now again by using the basic identity of the trigonometric function, that is what? Secant square theta minus tan square theta is equals to 1. Secant square theta minus tan square theta is equals to 1. So it means secant square theta minus 1 definitely equal to tan square theta by shifting this minus tan square theta towards right side and 1 towards the left side. So if tan square theta is secant square theta minus 1, tan theta should be equal to square root of secant square theta minus 1. So by using this identity, the dy by dx is equals to 1 divided by secant y as it is into tan y. So tan theta is root secant square theta minus 1. Then definitely tan y is root secant square y minus 1. So therefore dy by dx is equals to 1 divided by, from this equation number 1, secant y is x, so secant y replaced by x into root. If secant y is x, secant square y is equals to x square, so minus 1 as it is, and this is what? Derivative of secant inverse x, 1 divided by x into root x square minus 1. I hope all of you are understanding. Now the sixth, last one, that is what? If y is equals to cosecant inverse x, then prove that dy by dx is equal to minus 1 divided by x into root x square minus 1. So prove here y is equal to cosecant inverse x. Now shift this cosecant inverse to left side. Then cosecant y is equal to x. So we need dy by dx. Differentiate this with respect to x. So derivative of cosecant y is minus cosecant y into cot y, and y with respect to x is dy by dx equals to derivative of x with respect to x is 1. Therefore, dy by dx is equals to, shift this minus cosecant y cot y towards the right side, minus 1 divided by cosecant y into cot y. Now again by using the basic identity of the trigonometric functions. So that is what we know, that cosecant square theta minus cot square theta equals to 1. So it means cosecant square theta minus 1 definitely equals to cot square theta by shifting this cot square towards the right side and 1 towards the left side. So if cot square theta is cosecant square theta minus 1, definitely cot theta is equals to square root of cosecant square theta minus 1. So by using this, dy by dx is equals to minus 1 divided by cosecant y as it is into, so if cot theta is root cosecant square theta minus 1, cot y should be equal to root cosecant square y minus 1. So therefore, dy by dx is equals to minus 1 divided by, so from this equation number 1, if cosecant y is x, so cosecant y is replaced by x into square root of, if cosecant y is x, cosecant square y is x square minus 1 as it is, and this is what? Derivative of secant inverse x, sorry, cosecant inverse x, that is minus 1 divided by x into square root of x square minus 1. So I hope all of you understood proving the derivatives of formula for inverse trigonometric functions. Now we need to solve finding the derivatives of inverse trigonometric based problems. So for that, first we need some basic formulas in the sense double angle formulas, which will be studied in the trigonometric functions, and also some properties of inverse trigonometric functions which are studied in inverse trigonometric functions chapter, that is what second chapter. So now just I want to recall all that required properties and required formulas to solve finding the derivatives of inverse trigonometric based problems. So first thing, double angle formulas. First thing is what? Double angle formulas. So the formula for sin 2 theta. So here we have two formulas for the sin 2 theta. So sin 2 theta, first formula is 2 sin theta into cos theta, and the second one is 2 tan theta divided by 1 plus tan square theta. And the next one, the formula for cos 2 theta. So here we have four formulas. Among that, the first one is cos square theta minus sin square theta, and the second one is 2 cos square theta minus 1, and the third one is 1 minus 2 sin square theta, and the fourth one is 1 minus tan square theta divided by 1 plus tan square theta. So these are the formula for cos 2 theta. And the third one, The formula for tan 2 theta. The formula for tan 2 theta. So the formula for tan 2 theta is 2 tan theta divided by 1 minus tan square theta. And by using this cos 2 theta formula, 1 plus cos theta is equals to 2 cos square theta by 2. So minus 1 shift towards the right side. 1 plus cos 2 theta is equals to 2 cos square theta. So by using half angle formulas, 1 plus cos theta is 2 cos square theta by 2. And 1 minus cos theta is equals to 2 sin square theta by 2. So by using this formula, so shift cos 2 theta towards right side and 2 sin square 2 theta towards left side. It becomes 2 sin square theta is equals to 1 minus cos 2 theta. So for the half angle formulas, 1 minus cos theta is equals to 2 sin square theta by 2. And now we need some of the triple angle formulas also. So now what? Triple angle formulas. So the formula for sin 3 theta. 3 sin theta minus 4 sin cube theta. And the formula for cos 3 theta is what? 4 cos cube theta minus 3 cos theta. And the formula for tan 3 theta is what? 3 tan theta minus tan cube theta minus tan cube theta divided by 1 minus 3 tan square theta. Now some required properties of inverse trigonometric functions. So these properties are helpful to find the derivatives of inverse trigonometric based problems. So what? Properties of inverse trigonometric functions. Properties of ITF. ITF in the sense inverse trigonometric functions. So the first property, sin inverse of sin theta is equals to theta. And second one, cos inverse of cos theta is equals to theta. And the third one, tan inverse of tan theta is equals to theta. And the fourth one, cot inverse of cot theta is equals to theta. Secant inverse of secant theta is equals to theta. And the last one is cosecant inverse of cosecant theta is equals to theta. So these double angle formulas, triple angle formulas and properties of inverse trigonometric functions are helpful to solve the or find the derivatives of inverse trigonometric based functions or problems. Now let us start the first question. Find the derivatives of the following functions. The question is what? Find the derivatives of following functions with respect to x. Now some three properties are required to solve the derivatives of inverse trigonometric functions. So you need to note that also. The first property is sin inverse x plus cos inverse x is equals to pi by 2. And the second one is tan inverse x plus cot inverse x is equals to pi by 2. And the last one is secant inverse x plus cosecant inverse x is equals to pi by 2. So these are also important properties and which are helpful for finding the derivatives of inverse trigonometric based problems. So now the first question, find the derivatives of following functions with respect to 2x. So the first question is, if y is equals to sin inverse of 2x divided by 1 plus x square. So now we need to find the dy by dx. So observe here, y equal to sin inverse of something. So we know the formula for derivative of sin inverse x. So what is the derivative of sin inverse x? Derivative of sin inverse x is equals to 1 divided by square root of 1 minus x square. But here x is in u by v form. So to find out the derivative of this inverse trigonometric function, so it is very complicated. Complicated in the sense x is in the form of u by v form. So to find the dy by dx for this type of inverse trigonometric functions, first we need to write their simplest form. To write the simplest form of this given inverse trigonometric function, so observe here. So we already recall some double angle formulas of the trigonometric functions. We recalled what? Some double angle formulas of the trigonometric functions. That is what? The formulas for sine 2 theta, cos 2 theta and tan 2 theta. So observe here, y equals to sine inverse of something. First we need to use the property, that is what? Sine inverse of sine theta. That is what? Sine inverse of sine theta. We know that sine inverse of sine theta is equals to theta. So it means that first we need to express this sine inverse of sine of something. To express sine inverse of sine of something, so observe the term inside the bracket. If we use x equals to tan theta substitution, so it takes the form of sine 2 theta, that is what? 2 tan theta divided by 1 plus tan square theta. So therefore, to write the simplest form of this y equal to sine inverse of 2x divided by 1 plus x square, we use what? X is equals to sine tan theta. We use what? X equals to tan theta. So put x equals to tan theta. So therefore y becomes sine inverse of 2x in the sense 2 tan theta divided by 1 plus x square. X is tan theta, x square is tan square theta. Therefore y is equals to sine inverse of, we know that 2 tan theta divided by 1 plus tan square theta is the formula for sine 2 theta. And also we know the property of inverse trigonometric function, sine inverse of sine of something is equal to something. So here something is 2 theta. Therefore, so finally we get y is equals to y is equals to 2 into theta. What is theta? So here, so substitution is what? X equals to tan theta. So by using this substitution, we can write theta is equals to, shift this tan towards the left side, it becomes what? Tan inverse x. Therefore, if y equals to 2 theta, definitely y is what? 2 into tan inverse x, because theta is tan inverse x. Now we got simplest form of this given inverse trigonometric function. So now we can easily differentiate. So therefore, differentiate this with respect to x. That is what? Dy by dx is equals to 2 into, so we know the derivative of tan inverse x formula. So derivative of tan inverse x is 1 divided by 1 plus x square. So finally we got dy by dx is equals to 2 divided by 1 plus x square. I hope all of you understood. Now the second question, find dy by dx for the function if y is equals to cos inverse of 1 minus x square divided by 1 plus x square. So we know that derivative of cos inverse x is equals to minus 1 divided by root 1 minus x square. But here cos inverse of x is in a u by v form. So it is complicated to find out the derivative of this cos inverse of 1 minus x square divided by 1 plus x square. But if we write this cos inverse of 1 minus x square divided by 1 plus x square in the simplest form, it is very easy to find out the derivative of this function. So to write the derivative of this function, first observe the term inside the bracket. If we use any substitution, is it takes any standard formula format. So recall the double angle formulas. In that the formula for cos 2 theta. What is the formula for cos 2 theta? We have four formulas. In that, one of the formula is 1 minus tan square theta, 1 minus tan square theta divided by 1 plus tan square theta. So on comparing these terms, if we substitute x equals to tan theta, so it is of the form cos 2 theta. So therefore, to write the simplest form of this function, I am going to substitute here x is equals to tan theta. So therefore, y becomes what? Cos inverse of 1 minus x is tan theta, x square becomes tan square theta divided by 1 plus x square means tan square theta. I hope all of you understanding. Now, y is equals to cos inverse of 1 minus tan square theta divided by 1 plus tan square theta is the formula for cos 2 theta. Now again by using the property of inverse trigonometric function, we know that cos inverse of cos of something is equals to something. So here something is 2 theta, therefore y is equals to 2 theta. Now again by using the substitution, what we substitute here, x is equals to tan theta. So if x is equals to tan theta, what is theta? Definitely theta is equals to what? Tan inverse x. So therefore from this substitution, y becomes 2 into theta. Theta is what? Tan inverse x. Now we wrote the simplest form of the given inverse trigonometric function. Now easily we can differentiate this. So what next? Differentiate this with respect to x. So derivative of y with respect to x, dy by dx equals to 2 into derivative of tan inverse x is 1 divided by 1 plus x square. Therefore, dy by dx is equals to 2 divided by 1 plus x square is the required dy by dx for the given inverse trigonometric function. Now let us start the third question. So now the third question, if y is equals to tan inverse of 2x divided by 1 minus x square. Now again we know the formula for derivative of tan inverse x. So what is the derivative of tan inverse x? 1 divided by 1 plus x square. But here x is in u by v format. So first thing we need to write this given inverse trigonometric function in the simplest form. To write the simplest form of this given inverse trigonometric function, first we need to observe the term inside the bracket. So the term inside the bracket is 2x divided by 1 minus x square. Now recall the double angle formulas. In that tan 2 theta formula. So what is the formula for tan 2 theta? 2 tan theta divided by 1 minus tan square theta. So if we replaced this x by tan theta, definitely this term takes the formula of the tan 2 theta format. So to write the simplest form of this given inverse trigonometric function, I am going to substitute what? X equals to tan theta. So if x equals to tan theta, definitely theta is equals to what? Tan inverse x. So therefore, y is equals to tan inverse of 2 into x. What is x? Tan theta divided by 1 minus x square means tan square theta. So now y is equals to tan inverse of, so this is a formula for tan 2 theta. So again, by using the property of inverse trigonometric function, that is what? Tan inverse of tan of something is equals to something. So here something is 2 theta, therefore y is equals to what? 2 theta. So again, using the substitution, y becomes 2 into theta is what? Tan inverse x. So 2 tan inverse x. Now we wrote the simplest form of given inverse trigonometric function. So now we can easily differentiate this. So differentiate this with respect to x. Derivative of y with respect to x is dy by dx, which is equals to 2 into derivative of tan inverse x is 1 divided by 1 plus x square. Therefore, required dy by dx is equals to what? 2 divided by 1 plus x square. I hope all of you are understanding. So let us start the next question. Find the dy by dx if y is equals to tan inverse of 3x minus x cube divided by 1 minus 3x square. So here we need to find the derivative of what? Tan inverse of 3x minus x cube divided by 1 minus 3x square. So again it is of the form tan inverse x format, but here x is in a u by v form. So it is complicated to find out the derivative directly by using the tan inverse x formula. So therefore first we need to write this given in a simplest form by using one of the substitution. So for the substitution, first we need to observe the term inside the bracket. So recall the formula for tan 3 theta. What is the formula for tan 3 theta? We know that tan 3 theta is equals to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. So if we use the substitution x equals to tan theta, is it the term inside the bracket takes the formula of tan 3 theta format? Definitely 3 into tan theta minus tan cube theta divided by 1 minus 3 tan square. So to write the simplest form of this inverse trigonometric function, so use or put what? X is equals to tan theta. So if x is tan theta, definitely theta is equals to what? Tan inverse x. So therefore y is equals to tan inverse of 3 into x, x is what? Tan theta minus x cube. X cube is what? Tan cube theta. If x is tan theta, definitely x cube is what? Tan cube theta divided by 1 minus 3 into x is tan theta, x square is tan square theta. I hope all of you are understanding. Therefore, y is equals to tan inverse of 3 tan theta minus tan cube theta divided by 1 minus tan square theta is the formula for what? Tan 3 theta. Now again by using the property of inverse trigonometric function, tan inverse of tan of something is equals to something. So here what is a something here? Something is 3 theta here. Therefore, y is equals to what? 3 theta. Now by using the substitution, y becomes, y is equals to 3 into theta. What is theta? So theta is tan inverse x. Now we wrote the simplest form of the given inverse trigonometric function. So we can easily differentiate this. So differentiate this with respect to x. So dy by dx is equals to 3 into derivative of tan inverse x is 1 divided by 1 plus x square. So finally we got dy by dx is 3 divided by 1 plus x square. I hope all of you understanding. Now the next question. Find dy by dx. Find dy by dx if y is equals to sin inverse of 2x into square root of 1 minus x square. So now we need to write the or find the derivative of this. Y is equals to sin inverse of 2x into square root of 1 minus x square. So here we know that the derivative of sin inverse x. What is the derivative of sin inverse x? 1 divided by square root of 1 minus x square. But here x is what? 2x into square root of 1 minus x square. So it is complicated to find out its derivative. So for that first we need to write this given inverse trigonometric function in simplest form. So to write the simplest form of this, we use some identities. So observe here, under square root here exists 1 minus x square. So recall the identity, that is what? We know that sin square theta plus cos square theta is equals to 1. So it means if we write the formula for cos square theta is what? 1 minus sin square theta. So it means what is cos theta? Which is equals to square root of 1 minus sin square theta. So therefore, observe the terms in the given inverse trigonometric function, square root of 1 minus x square is exist. We got by this basic identity, cos theta is what? Root 1 minus sin square theta. So observe these two terms. If we replace x by sin theta, we got what? Cos theta. So it is helpful to write the simplest form of this given inverse trigonometric function. So for the simplest form of this given y, I am going to substitute x is equals to what? Sin theta. So if x is equals to sin theta, definitely theta is equals to what? Sin inverse x. So therefore y is equals to sin inverse of 2 into what is x? Sin theta into square root of 1 minus x square in the sense sin square theta. So now y is equals to sin inverse of 2 sin theta into what is square root of 1 minus sin square theta? Is it equal to cos theta? So cos theta. Now observe the term inside the bracket. Sin inverse of 2 sin theta into cos theta is a formula for sin 2 theta. Again by using the property of inverse trigonometric function. That is what? Sin inverse of sin of something is equals to something. Here what is something? Something is 2 theta. Therefore y is equals to 2 into what is theta? Theta is what? Sin inverse x. So 2 into sin inverse x. Now we wrote the simplest form of given inverse trigonometric function. Now easily we can differentiate this. So now what? Differentiate this with respect to x. So dy by dx is equals to 2 into derivative of sin inverse x is 1 divided by root 1 minus x square. Therefore dy by dx is equals to 2 divided by square root of 1 minus x square. I hope all of you understanding. Now the next question is find dy by dx. Find dy by dx for the function y is equals to sin inverse of 1 minus x square. Find dy by dx for the function y equal to sin inverse of 1 minus x square divided by 1 plus x square. So by observing the term inside the bracket, definitely we are going to substitute what? Tan theta. Put x is equals to tan theta. So it means what is theta? Theta is tan inverse x. Therefore y is equals to what? Sin inverse of 1 minus tan square theta divided by 1 plus tan square theta. So therefore y becomes what? Sin inverse of 1 minus tan square theta divided by 1 plus tan square theta is a formula for cos 2 theta. Now observe here, we know the property sin inverse of sin of something, or we know the property cos inverse of cos of something. But here we got sin inverse of cos of something. So first we need to convert this in a standard inverse trigonometric function property. To convert that, so this can be converted in two different methods. First by using the property of inverse trigonometric function. That is what? We know that sin inverse x plus cos inverse x is equals to pi by 2. So therefore, now it is of the form sin inverse of x. What is x here? This entire cos 2 theta is the x. So sin inverse of x. Sin inverse of x. By using this, we can write sin inverse of x is equals to pi by 2 minus cos inverse of x. So therefore, by using property, this y becomes what is y? Sin inverse of cos 2 theta can be written as y is equals to, now observe here, sin inverse of x equal to pi by 2 minus cos inverse of x. Cos inverse of what is x? X is entire cos 2 theta. So in place of x, I am writing what? Cos 2. I hope all of you understand it. Now y is equals to pi by 2 minus. So now it is of the form cos inverse of cos of something. So something is 2 theta. Or this can also be converted by using the allied angle formulas. Now observe the second method here. So I am going to write what? Second method. So you may follow first or second method. ನಿಮಗೆ ಯಾವ್ದು ಈಸಿ ಆಗುತ್ತೋ ಅದನ್ನು ಫಾಲೋ ಮಾಡಬಹುದು. So by using second method, y can be written as, observe here, y is equals to sin inverse of, so cos 2 theta by using the allied angle formula, we may write it as sin 90 minus theta. What is theta here? 2 theta. So sin 90 minus theta is cos theta. So hence sin 90 minus 2 theta is equals to 2 theta. Now this can be also written as y equal to sin inverse of something is equal to what? Something. What is something here? Pi by 2 minus 2 theta. So you may follow this method or by this method. So both are same. ನಿಮಗೆ ಯಾವುದು ಈಸಿ ಆಗುತ್ತೋ ಅದನ್ನ follow ಮಾಡಬಹುದು. Now, so I am writing here R. So you may follow any method. Now y is equals to pi by 2 minus 2 into theta. What is theta? So theta is tan inverse x. Now we wrote the simplest form of given inverse trigonometric function. Now easily we can differentiate this. So differentiate this with respect to x. So dy by dx is equals to pi by 2 is a constant, derivative of constant is 0, minus 2 as it is because it is in a multiple of tan inverse x. So 2 as it is, derivative of tan inverse x is 1 divided by 1 plus x square. So finally required dy by dx is equals to minus 2 divided by 1 plus x square is the answer. I hope all of you understanding. So now the next question is, find dy by dx if y is equal to cos inverse of 2x divided by 1 plus x square. So by observing term inside the bracket, what we substitute here, x equals to tan theta. So it becomes theta tan inverse x. Therefore y becomes what? Cos inverse of 2 tan theta divided by cos inverse of 2 tan theta divided by 1 plus x square means tan square theta. So therefore y is equals to cos inverse of, we know 2 tan theta divided by 1 plus tan square theta is a formula for sin 2 theta. Again observe here, we got cos inverse of sin of something. So it means we need to convert this sin inverse of sin of something or cos inverse of cos of something. So already we know two methods how to convert this in a standard property format. So this can be written as y is equals to, I am going to convert by using the allied angle formula, cos inverse of cos, sorry, sin 2 theta can be written as cos of pi by 2 minus 2 theta. So because we know that cos 90 minus theta is equals to sin theta. Here theta is what? 2 theta. Therefore cos 90 minus 2 theta definitely is equals to sin 2 theta. So therefore there is no difference between these two statements. So now y is equals to, we know that cos inverse of cos of something. What is something here? So something is pi by 2 minus 2 theta. So therefore cos inverse of cos pi by 2 minus 2 theta is pi by 2 minus 2 theta. I hope all of you understanding. Now y is equals to pi by 2 minus 2 into, so by the substitution only we know that what is theta? Theta is tan inverse x. So 2 tan inverse x. Now we wrote the simplest form of given inverse trigonometric function. So easily we can differentiate. Differentiate with respect to x. So dy by dx is equals to, derivative of pi by 2 is 0 because it is constant, minus 2 into derivative of tan inverse x is 1 divided by 1 plus x square. So finally we got dy by dx of the given function, that is what? Dy by dx is equals to minus 2 divided by 1 plus x square. I hope all of you understood.